This is Joe narrating a PowerPoint in science in a unit on physical science. It's lesson 2, properties and states of matter. This is found on page 544 in the Kaplan book. You should be familiar with these vocabulary words. For example, matter is anything that has mass and takes up space. You should know the difference between mass and weight. You should know the terms for the states of matter, solid, liquid, or gas, and you convert from one state to another by either adding heat or removing heat. You should know what a crystal is. You should know what the melting point and freezing points are, the boiling points and the condensation points are. You should know that a solution is made up of a solvent and a solute, and you should know that an alloy is just a solid solution. So matter is anything that has mass and takes up space. Often we use the terms mass and weight interchangeably, but mass is really the amount of matter in an object, and the weight is a measure of the gravitational attraction between the object and the planetary body that it's on. For example, if a person weighs 120 pounds on Earth, their weight on the moon would be 1/6 of that, or about 20 pounds. So the weight differs even though the amount of material in that person is the same. So their mass is the same in both places, but their weight is different whether they're on Earth or on the moon. There are 3 common states of matter: solid, liquid, or gas, and we are all familiar with these. Solids tend to be rigid, they have a fixed shape, and they have a fixed volume. They can stand on their own, and it's very hard to compress or squash a solid. A liquid is not rigid, it has no fixed shape, but it does tend to have a fixed volume, meaning it's resistant to being compressed. Gases are not rigid, they have no fixed shape, and they have no fixed volume. A gas will expand to fill the container in which it is contained, and you can compress a container that has gas in it. So we change matter from one state to another by either adding heat or removing heat. So you're familiar with ice. If you have solid ice, which is just solid water, if you add heat to water, it will change. If you add heat to the ice, it will change to a liquid form, or liquid water. And if you add even more heat, that liquid water will change to steam, or water in the gaseous state. You can also go the other way. You can take steam, remove heat, it will condense to become a liquid, and if you remove heat from the liquid, it will freeze to become a solid. This is an example of a crystal. These are magnified crystals of table salt. So crystals are solids in which the substance making up the crystal is arranged in an orderly pattern. It tends to give the crystal distinct shapes. For example, here these are like little rectangles. So in this graph, time is on the x-axis going from left to right, and the temperature of the substance is on the y-axis going from a lower temperature on the lower left to a higher temperature on the upper left. As you heat a solid, you add more heat to it, and over time the solid will become a liquid. At the point where the solid becomes a liquid, we say that is the melting point. If you continue to heat the liquid will change into a gas. The point at which it changes from liquid to gas is called the boiling point, and we are familiar with these terms when applied to water, but most substances that are in solid form can be changed to liquid or gas. For example, if you take a piece of iron, you can change that to liquid iron by adding enough heat, and you can change it to gaseous iron by adding even more heat. Now this graph is arranged in a different format. because we are removing heat from a substance. So on the x-axis we have time again, and on the y-axis we have temperature, but we're starting at 0 degrees and we're going down in temperature. I'm sorry, we're starting at a certain temperature and going down in temperature from left to right. So if you start with a gas, you remove heat from the gas, it will then condense into a liquid. The point at which that happens is called the condensation point. This is the opposite process of boiling. If you continue to remove heat from a liquid, it will freeze. At the freezing point, it will go from liquid to solid. This is the opposite of melting. So it's just showing it from two different perspectives, the last slide and this slide. The condensation point is the same point, same temperature as the boiling point, and the freezing point is the same temperature as the melting point. It just depends on which direction you're going from the point of gas to solid by removing heat, or from solid to gas by adding heat. This is a glass of ice water. The temperature of this water will stay the same, 32 degrees Fahrenheit, until all the ice is melted, and then the room temperature will affect the remaining water and make the temperature of the water go up. But at this temperature in this room, you can see the beads of water on the outside of the glass because the water vapor in the air is condensing onto the glass because of the cold temperature of the glass. So the water vapor is a gas in the air. It's condensing into liquid water on the outside of the glass. A solution is just a solvent and a solute. The solute is the substance that's in the solution, and the substance in which the solute is dissolved is called the solvent. For example, if you add sugar to water, the sugar will dissolve in the water, and you will have a sugar solution. You can have a salt solution by dissolving a solute like table salt, sodium chloride, into water to have a solution of salt water. So the solid that dissolves in a liquid is called a solute. The liquid in which the solute dissolves is called the solvent. When you combine them, you get a solution. You can end up with a solid solution. For example, you can make a solution of two different metals, and when that solidifies or turns from liquid to solid, you will essentially have a solid solution. You carry around these solid solutions or alloys in your pocket all the time. Pennies are basically a solution of zinc and copper. That's it for the lesson on properties and states of matter.